Welcome to the ML Platform Podcast, brought to you by Tecton AI, the show where Piotr Niedźwiedź and Aurimas Gricinas, together with top MLOps practitioners, explore the world of internal ML platforms and MLOps stack components. Today we brought Michael Balso from Tecton to talk about building ML platform at Uber and real-time feature management.
This is going to improve things by 0.01%. And that's, we made, X million dollars today. Came back the next day and he goes, all right, we have 6,000 features in the feature store already. It's like, that you want to pass into prompts for LLMs, right? And that use case, I don't know the future of it.
Now onto the show.
Hello, everyone, and welcome to a machine learning platform podcast. As always, I'm joined by my co-host Piotr Niedźwiedź, who is founder and CEO at Tecton AI. And today I'm super excited because as a guest, we have none other than Mike Del Balso, who is a CEO and co-founder of Tecton, which is a probably most popular and well-known featured platform out there. Mike has also been a product manager for the legendary Michelangelo machine learning platform at Uber. And he's behind the very well-known Uber's blog post about Michelangelo as well. Hi, Mike. Would you mind introducing yourself a little bit more to our listeners?
Yeah, thanks for having me, guys. This should be a fun convo. A little bit about my background. So I've been in machine learning for a while. I used to work at my first job out of school. I worked at Google, and I luckily rotated into being the ads team. And I didn't really know what I was getting myself into, but I kind of became the PM for machine learning for Google's ads, like the ads you see on the website when you type search into Google. So every time you type a search, there's an auction that runs, and we had a bunch of machine learning signals in real time that would feed into that auction. Things like
Mike, because it was your first job, right? After school. At the same time, as far as I know, I was doing internship at Google, but at least at that time, and I think it is still correct, ad business is the biggest business of Google. So it sounds you've been put.
It was a really weird situation. So I can give you more details.
Business of Google, yeah. How it happened? How it's possible to?
Yeah, I'll give you guys a little bit more details. So I was part of a program called Associate Product Manager program. So that's a program where it's like how they hire product managers, kind of like a training program, kind of like a rotational thing. So I kind of skipped over a detail, but it's 2 rotations. My first rotation was actually on Google Maps. But then my second rotation, I was like, I want to go to ads. The reason I wanted to go to ads was because I thought, if you know how advertising works, that's kind of like the lifeblood of the internet. Then you know how the whole internet works, basically. You know how all the economics of the internet works. So I looked for a role there, and I got a job, and so I skipped a couple steps, but if this is interesting, I'll kind of go into some details. I was placed on a team called Click Quality. So Click Quality is one of the signals. It basically, like, what it represents to Google is what's the, if you click on this ad, how likely is it that the user is going to have a good experience? So we were estimating that with machine learning. So we were looking at things like, do people stay on that web page for a long time, or do they go back right away? Or what's when we look at that web page itself, is there high quality stuff, or is it lots of ads and it's like a terrible website? So that's what my team was. Like, the really big thing in ads at Google is basically like predicting if you're going to click, called PCTR, predicted click-through rate. So for every impression, we would generate a score saying, are you going to click this ad? And then that would influence the auction and the ranking of the ads, right? Because Google wants to show you ads that you're going to click, and it gets paid when you click the ad. So, over time, I kind of like grew and took on more and more of the machine learning things. I was on that team for about 3 years. So it's not like I was like right out of school and suddenly I'm running the whole thing, but just kind of took on more responsibility over time. But you're right that was like, I don't remember the exact number, but it's something like more than 90% of Google's revenue flows through just that exact.
It is the number I remember. I was not sure whether I can reveal it.
No, I think it's like public. I mean, that's not even an exact number, but it's something like that. And the cool thing about it was, I mean, there's a couple of cool things. Yeah, I guess we can go into details on this because this is like all about machine learning platforms. But so we were on this team where we were. So actually, just to give you a sense of what this team is, this team had some of the smartest people I've ever worked with. Do you know the machine learning paper, Machine Learning the High Interest Credit Card of Technical Debt? So that's the team that wrote this paper. Like my tech lead, my engineering manager guys wrote that paper while I was there. I was too junior. They didn't invite me to write the paper.
So you're not listed as an author, but you are close.
I was like there with them. I have nothing to do with the paper, but to give you a sense of like, those are the kinds of problems we were solving, right? We were like, how do we, so the problem is for every single search on Google, which was billions per day, how do you rank these thousands of ads in real time to optimize all the dollars that Google gets, right? And if you can get a 1% change, if you can like make a change to your model and it's 1% better, then you're getting like literally hundreds of millions of dollars for Google. It's huge, you know. And so by the time I was there, and people had been working on this for a long time, by the time I was there, you know, we had a scale of data, and we had a quality of tooling that allowed us to be able to get statistical significance on measurements of changes that were like, this is going to improve things by 0.01%, and that's, oh, we made, you know, X million dollars today on a daily basis. So anyway, so very. I think I thought of it as the best productionized machine learning system in the world at the time, honestly. It probably still is, but just because of how important financially, economically it is just for the whole internet, right? And it's not just about Google. Like if we screwed something up, there would be a whole, you know, maybe like all of the travel industry just wouldn't get revenue for a day until we fixed it or something like that. So it was a big impact. And there was a lot of people working on this stuff. We were mainly using logistic regression back in the day, just a gigantic logistic regression system. And while I was there, we were working with the early TensorFlow team and kind of migrating things and doing the early experiments to bring things into the deep learning world.
But when you were, Mike, when you were using logistic regression, why TensorFlow?
No, that we were moving away from logistic regression to
you wanted to do something more
to adopting deep learning, yeah, and yeah, and it was like the most complicated logistic regression thing I'm pretty sure that you could find anywhere, because it had 20 years of engineering behind it.
So you had to have a lot of features at that time as well, right? Like
thousands of features, really complicated features, real-time serving, real-time learning, models updating constantly, model chains, dependencies, features that had their own crazy data pipelines that would, like, we would have interns on the team who would be PhDs in whatever, some math thing, and they would come in for a summer, and their whole internship would be, let me turn this crazy math thing, this new thing I did with Bayesian nets or whatever, into a feature and see if it helps these models. That would be your internship. And sometimes it would work, sometimes it wouldn't. And even we were experimenting with reinforcement learning at the time in the models. A lot of those people ended up joining DeepMind and are there today. So kind of like a cool place to be, lucky place to be early in your career. But think of that as just like the best productionized, like it was like super productionized, kind of the stuff where you can bring that to a machine learning team today, like any company that's a normal company, and they'd be like, I don't actually need what Google's doing. Google's doing this really crazy advanced thing. Hundreds of engineers building that infrastructure, like billions of dollars that come out of it. So it's kind of a different scale than most people need.
And that was what, 2013?
Yeah, I was there from 2012 to 2015. So yeah, around then.
And where you were at the time where you were living, you've been product manager at Google?
Yeah, I was product manager the whole time. Yeah. And then around 2015, I got a call from Uber, and Uber was basically, this is the situation they were in. They were like, hey, we've got all of this unique data, right? Like nobody else has this data about like people's locations like this, and travel, and cars and cities and drivers and riders and stuff like that. And so we have more data than anybody else about this thing. And we're currently in the spot where we're just trying to like figure out like literally like how to store it all. Like they were kind of in the very early days of just getting their data stuff together. They were building the first data team, but they were thinking about like, we've got a lot of data scientists here. We know we can do a lot of cool stuff with this data. What can we do to impact our users with this data? We know how to use this data to do analyses and find patterns. And we've done a lot of stuff successfully with that, kind of like internal investigations, kind of internal analyses for internal stakeholders. But how do we kind of activate this data to allow us to have a better product for our customers, to build new products, to drive our systems with data-driven automated decisioning, right? So you want to do that. You can't have a human in the loop, and it's at a scale where also, it's like a speed and a scale that doesn't make sense for a human. And that's basically perfectly what machine learning is for. So the idea was like, how do we enable machine learning at Uber? How do we make machine learning possible? And so they said, hey, can you come help us do that? So I joined, and there was a team of like maybe 5-ish people. It was me and a couple of engineers. And so I was the product manager, and we were like the machine learning team. And our task was to, democratize machine learning at Uber. And
how if I may, so it sounds like you join Uber to lead their ML. Like today, those teams are called ML platform teams very often. Your paper, right? Uber's machine learning platform. It sounds like you've been a leader of one of the first ML platform teams, if not at Google, at Uber at least. But when I was reading, it is how I met you, like via paper. I read the paper. It is when I first heard about you. But it is 2 years later after you join Uber. But when you join, you were forming the platform team. It sounds like that. You said democratizing, but democratizing words, not sure whether it is so often used anymore, but used to be used so often that I don't know what it means. So like, what was when you were hired, how you measure the success? What was the first milestone? How to start building ML platform team?
I think a lot of things are a lot more clear when you look back in time, you look retrospectively. At the time, it was just like, we're building this thing to enable data scientists, and we didn't really have it wasn't as obvious to us. We didn't know like how successful we could be or how much value this thing could unlock, but it was just clear that there was a lot of data scientists who were not able to get things into production. We didn't think, I have to say, we weren't thinking as much about the theory of the data science life cycle and how MLOps wasn't a term, but like how that stuff should work. It was more like, hey, there's a bunch of problems where people should be using machine learning and they're not, so go figure it out. So we had a couple of projects that were kind of like the first projects who were signed up to be our customers. It was 3 of them. And I kind of inherited those, and actually this is maybe a good lesson for everybody, but you got to be careful as an ML platform team who you work with, and especially the first people you work with, because I think most of the 2, if not all 3 of those first 3 projects were complete failures. They were complete failures not because the machine learning didn't work or something, but it was literally an organizational thing where one project didn't make any sense and there shouldn't have been. It was just a dumb project. The other project, they got reorganized or something, and so we spent a bunch of time on it, and then just it wasn't important after. And I think the third one, I think it just didn't. The data science side of it didn't end up working out. But if I was going to choose, like today, if I was going to do it, I would have a much better appreciation for how to, or I would think a lot more closely around like, how do I choose which internal customers I want to get as a platform team? I really care about getting like some quick wins to show off the value of the system. I also care about focusing on teams where there's actually value to the company. There's all kinds of different projects that people, some companies that have all kinds of different projects, but you want to find as the platform team, as the enabling group, the one that's actually driving the business and focus on them quite a bit. Because
it's very interesting what you're saying. It's not intuitive, because when you're shaping platform team, their goal is help other teams, right?
Let me work with anybody. I'm looking for anybody that wants to work with me, kind of thing.
But I also saw a pattern where you are starting from those who are struggling the most. But very often the teams that are struggling the most are not struggling because it's technically problematic. Very often it's business-wise problematic. That's why nobody cares. And it sounds like maybe the better strategy, at least to have a balance, like to have at least semi-successful team first, as among your first internal customer when you're building a ML platform team.
Yeah, and I think this is like a thing that we've gotten. At Tecton, we're a platform team too, right? We sell to not internal customers, but external customers.
Platform team.
Yeah, and we have to, prioritize who. Like a lot of people want to work with us, and we have to choose who we want to work with. And we think a lot about like, is this thing actually going to matter to these people? Is this a high value thing for this customer or not? And a variety of other like dimensions. And I'll tell you what I did at Uber, which I thought was, I don't know, maybe somebody suggested it to me, but it ended up being pretty helpful. What I did was I just went around and I was like, I'm going to meet every single data science team in the company. And so I went and talked to every data scientist, and I made a spreadsheet where I literally said, like, I tracked what is the data science problem they're solving, and then a whole bunch of things related to it. Is this something that we can help with? Is it valuable? Does this team want us to help with it? Is this team capable of owning this project after we help them with it? Is this team sophisticated enough to work with us? Like probably a couple other things like that. And we kept learning like other questions. Like we'd want to work with somebody and then we'd be like, oh, well, this wasn't a good fit for this reason. Like, do they have data collected? Do they have data? That's another column.
So these free teams, the first ones. So when you built some capabilities for them, I guess, right? Did you manage to reuse whatever you built for them?
Yes. Good question. Yeah. So we were building a very generic, I think like a pretty generic system, and I can say we went down like the wrong path. Like I remember we were able to reuse some stuff, we were not able to reuse some stuff. And it wasn't obvious at the time what fits in an ML platform. So we had to, like, I just remember one team was doing this weird algorithm thing, and I don't even recall us talking about like, hey, that's not a thing that nobody else wants. We just thought that's a thing that has to be built here. And now it's much more clear. Like it's pretty, if you work in this space, you kind of know that's what belongs in ML platform. That's what does not. And that wasn't super clear at the time. But I think we evolved that.
Do you remember an example of particular example of something that people thought should be part of ML platform, but from today's perspective, obviously it's not?
I think the example that I'm thinking of is, and there's a couple examples like this where, so just to bring everybody back in time to like 2015, 2016, there was a lot of like a bespoke data science. So what that means is like, there was a lot of, you go to a data science project, choose a random data science project, the data scientist often is not someone who worked as a data scientist in a tech company with a certain set of tools for a long time. Data scientists at Uber and many other companies at the time got that title through one of a few different common paths. Either they they were like a data analyst. They were like someone who's really good at SQL, and then they kind of wanted to get a little more technical. They got promoted and stuff like that. Or the other common path is they were someone who was like a grad student in statistics, and they learned a little bit of CS, and then they became a data scientist. And what we found was that the people who were like that second path, they kind of naturally tended towards doing more complicated modeling things than may have been justified. So they would, like, I just remember the specific thing where this guy wanted to do this model where it was like multi-stage model where you're continually predicting the errors of the previous stage model and trying to like do this in many stages, which is a little bit like kind of like what a tree-based model already does in one package by itself. But he was trying to build it in multi-stage, and it was kind of just a thing where it was like we spent a bunch of time with him trying to understand what he wanted to do. But like nowadays you wouldn't do, you would just be like, let me just use an ML package that's just gonna like make this prediction. The ML packages weren't as advanced in that time at that time either, so even that kind of like abstraction wasn't as obvious, it wasn't as prominent. So we wasted a bunch of time like digging into seeing if we could improve the ML libraries as well. And that I think was probably not the right place for us to spend that time. So like over time we evolved to, let's just use common ML libraries. You know, we later took on TensorFlow, but I think we just started with XGBoost, H2O, and there's one other one that will come to mind. And we were like, we're not going to like dig into that and get involved in that. So that's, I don't know, hopefully that makes sense as an example.
Today, I think the libraries are so generic and powerful that it is hard. Usually you will be fine. You don't need to be more creative than what is already there.
Yeah.
Yes.
Yeah. And it would be like, you would need a really good reason to like have to go and rebuild that library or something like that. But it was, you didn't need as good of a reason before. And so it wasn't as obvious that that was a bad direction to go into.
They're already so complex that for one person, it is maybe too challenging, very often too challenging to try to, you know, customize it even further. But 8 years ago, it was a different story.
From what you were telling, Mike, it seemed like the main problems initially were kind of related to the modeling part itself. When did it start becoming more data related, or were there data related problems as well from the very beginning?
So we took on the whole problem right from the beginning. And I actually remember us like thinking about and working on a feature store very early on. But it wasn't, you know, it took us a while to get our first things in production because there's a lot of stuff you got to build. You know, we were starting from zero, and it wasn't until later that we realized the importance of all of the data things, the feature platform side of things. But certainly at first we thought it was about the models. We thought we're going to help people train models, productionize models, and we thought this was going to be like a model management system. And then we thought, you know, maybe we'll have some like stuff that'll help people like build features faster. What we found though, after like when we really started getting this thing going and we really learned how to unblock data science teams, was that, well, okay, so what we found was we were helping these teams, and then as we were helping them, we were doing all this manual data engineering work again and again, and that data engineering work was the same work. It was like the same thing again and again. And so we began, you know, thinking, why don't we automate and centralize this stuff into the ML platform? Because the data engineering work that we were doing, and let's talk about what that is. It's like building the pipelines to compute features regularly. It's building the pipelines to store features and serve them quickly for real-time inference. Building the pipelines to compute these features for training time and assemble them into training data sets, to generate the training data sets, and building the pipelines to like monitor this stuff and log it and everything like that. We were doing that, you know, for each different project. And then we were like, it's the same thing every single time. Let's just automate and centralize that into the ML platform. That's what we called Feature Store. We started calling it a feature platform. And it was pretty cool. Like we had, I remember one of our engineers going, this is cool because now I can just make a bunch of features and have them kind of be like our central feature library for the whole company, for all of Uber. And I remember telling him, that's cool, like go do that. I thought he was going to make 12 features. And he came back the next day and he goes, all right, we have 6,000 features in the feature store already. And I was thinking, like, how did you do that? But he scripted something and it auto-generated a ton of features. And those features became like the default features that someone would use in almost like every ML model. It was stuff like details about a rider, details about a driver, about a trip, like basic things that we had point in time values tracked so we could generate a training data set. It was already wired up for serving and training and stuff like that. And so the value of that is it allowed a data science project to hot start. There was not a cold start situation where they're like, I want to build a model. Okay, I'm starting from zero. Even if they didn't do any feature engineering, they had a central library where they could at least pull some really good data, some really good features about all of the business concepts that we have, and get something going and see, is it even possible to predict this thing? Of course, you will do like specific feature engineering if you have a unique data set and stuff like that. But that became like a really nice system that we added to the platform, and we started it pretty quickly, but we learned pretty quickly like the value of it, and it became a pretty central source of value in the whole platform. It was one of the things that attracted people to using Michelangelo at Uber.
To me, like the Michelangelo paper was almost about feature stores and feature pipelines, right? Because
really, for me, it sounded like end-to-end platform. It was
a monitoring piece,
about deployments, monitoring.
Yeah. But the initial picture, right? It's a lot about movement of data. How
let's ask Autor. Is it end-to-end or is it a feature store? Was it a feature store?
So Michelangelo was about this end-to-end ML platform, and there's a bunch of like lessons there too. But like we didn't think of our team as we're building a feature platform. We thought of it as we're helping teams build and deploy machine learning applications, and so we're the ML infrastructure group. So we weren't constraining it just to feature platform. But I think what you're referring to, Arimas, is like when you look at like what we actually, we talk about all the parts of the ML platform in the blog post, but when you look at what the actual infrastructure diagram, the architecture is, it's like 80% of it is related to like feature stuff. There's a whole bunch of stuff around regularly computing features, putting it into online. We used Cassandra for an online feature store, so storing it there, having a feature server, be able to pull those features, do some real-time compute on that, like all kinds of stuff. And then there's like some little part where it's like, and we'll do model training and we'll do model serving. So a lot of the work in these systems, depending on how you define the scope of your ML platform, is all of this data stuff for sure.
I need to ask you, Mike. I asked Aurimas this question when we met first time. We met first time on our podcast. Aurimas was a guest, and I asked Aurimas why we are not including model serving as a part of feature store. You just did it like you also pick it like that, feature store and serving part, right? At the same time, you said before that some of the feature transformations are quite complex. What is the difference? Why a model inference is not just a complex feature transformation?
It kind of is. It's honestly, it's not like there's no like big religious like element here where we're not in a position where we would say for sure we would never serve a machine learning model or something. I think for us though, we found, so okay, let's fast forward to like today. I run a company called Tecton. So basically from doing all this stuff at Uber, Michelangelo, we recognize the value of all this feature engineering part of the ML platform. And so myself and the eng leads of Michelangelo, we left Uber and we started Tecton. And so Tecton is all about building kind of like the industry's, leading enterprise feature platform. So basically solving all those problems for somebody else. And if you go to like a Google, like I was saying, there's literally hundreds of engineers working on this stuff. You go to Facebook, they have hundreds of engineers working on this stuff. And we see ourselves as just like literally just, and our team is made up of people like who worked on those things. And we're just building that level of quality of infrastructure, the same reliability, performance, simplicity, and extensibility, and just making that available to kind of everyone who's trying to do, real-time machine learning. So, so why do we focus on that and not also machine learning models? And machine learning model serving and stuff like that. And so I think it's a little bit based on being very careful about the scope we choose. And the reason we have to be careful about the scope we choose comes back to a little bit of a lesson that I got from a mistake we did in Michelangelo. In Michelangelo, we built this end-to-end ML platform, which was cool. And we built it a little bit for like our first users, and it worked for the first users. And then, we go to users like teams 4, 5, and 6, and they go, yeah, like that's really cool. Like I like your thing, but I need a different way to do the serving, or I need a different way to do the training. And so Michelangelo at the time was this big thing. Imagine 8 different steps in the machine learning pipeline. You can, break it up however you want, but the chances for, if you're a new team, the chances that this whole thing is going to be a perfect fit for you in every single stage. Imagine each stage is 90% chance that it's going to like match your requirements. You kind of have like a 0.9 to the power of 8, right? 0.9 times 0.9 times 0.9. And so the realistic kind of end goal or end chances that the whole platform is going to work for you is actually pretty low afterwards. So we quickly realized we needed to break this thing up into different parts, make it more modular, so that people who have different requirements, because machine learning is a whole thing where every use case has different requirements. There's never 2 use cases that are the exact same, no matter what people say. And it'll be like, yeah, but I need to serve this model on the phone, or I need to serve this model in this way, or yeah, but we train with like a special kind of hardware, and or at Uber it was we serve the model on the car. We were doing self-driving cars at the time, any kind of thing, or we have a different kind of feature. Our features come from some other place. So we needed it to be like able to swap something out and swap in your custom module. And so, in breaking up Michelangelo, one of the things was just all the feature logic, all the feature infrastructure. And we found that the feature, now like looking broader, coming back to the tech, to the kind of like feature platform as a product in the market today, we found that the requirements that someone has with their feature engineering are not always super correlated to the requirements someone has for their model serving. So they're not like the exact same, they're not like highly correlated. So what I mean by that is there's people who will need a certain type of feature engine, like what you need in your feature compute and your feature infrastructure doesn't imply a lot about what you need from your model serving. And there's a whole space of different model serving things that you can do. And if you look in the market, there's 100 different companies that do model serving. We can probably name a bunch of them really easily. And so we thought, why, that's not our specialty. Let's just be really good at plugging into those things. I do think that in the future, we don't have anything against like, yeah, and we can also serve models. But I don't think like what we have built is necessarily like changing the game or a 10x better thing for model serving. And also as we kind of move forward now, we're seeing model serving and inference generally become a more complex thing, especially with GPU-based serving, bigger models.
Large language models, definitely.
Exactly, and it's just a deeper problem. And that means you're going to have more specific requirements for that, and that requires more and more focus. And so we're staying focused on our domain because we're kind of like really the only player that's doing this, like really at this quality. But I do expect like someday we'll move into that for sure.
I understand this argument it is very well because with Neptune, we are experiment tracker, right? We are also point solution. initially when we started Neptune, Neptune was a spin-off of my previous company, and it had infrastructure management part that would help, that you could use to train your models. But we also, like, for the very similar reasons, we decided to drop it and focus just on that. But we are. I'm sure that you are hearing those questions also. Sometimes ask, okay, but we also have end-to-end platforms here. Why shall I why shall I bother?
Yeah, why should I buy
my tech stack
when I can buy the whole thing from somebody, right?
Yeah.
And I'll tell you,
what is your answer?
I'll tell you, yeah, my answer I think is pretty simple. I think you got to kind of take you got to make a bet. You have to use some judgment on like how you think the machine learning market and the machine learning technology stack is going to evolve over time, right? And for us, I think the kind of the take that we have is that everything that's going on in MLOps, if you look at, this is the standard, everybody knows this, you look at the kind of like landscape diagram, and there's 4,000 companies, and maybe there'll be like bucketed
less and less, I think.
That's true, but you'll see like a box with a bunch of companies in it, and all those companies will kind of do different things, and so the geometry of different products is kind of unsettled. And I feel like we're going through, as an industry, like an annealing process, like a converging process, where we're slowly, some companies are working, some aren't working. We're kind of forming into what are the layers of the stack that the industry will converge to and will kind of be stable long-term like elements of the stack. And so my position on it is, of course, there's going to be some end-to-end ML platforms, but we're not really seeing end-to-end ML platforms work in for production purposes. People who are doing like real production in ML, and I'm talking about people who like are our customers, who are like, they're predicting fraud, they're doing recommendation systems, they're doing dynamic pricing, things like that. The variety, the variance of requirements, if you look at those use cases, is just so high that it's really hard for all-in-one system to ever be good enough often enough for many use cases, many customers. But we think that it's a lot more possible for you to build a really high quality system. And similar for experiment tracking, you could build the best experiment tracker and it could be good for all of those. But it's really hard to build the best experiment tracker and the best monitoring thing and the best training, whatever, all of those things, and have it all be. So that's just a bet that we have on how the industry is going to look 5 years from now. I think for production machine learning use cases, it's going to be mainly driven by components of an ML stack that work really well together, and combining best-in-class solutions rather than just like I don't think there's going to be like an all-in-one production ML platform that everybody uses.
Mike, okay, so there are many kind of domains where feature stores can expand upon. One of them is feature engineering, but I was thinking a little bit about the upcoming days of foundational models. And for example, and one specific thing that is in my mind is vector databases, right? Do you think there's a space for vector database capabilities in features platform offerings?
Yeah, absolutely, I do. And I can tell you about kind of like how they fit in today, and kind of how they fit into like the future as well. So it's really interesting. So what's cool about a vector database? I think the nice thing about it is it allows you to find similar things. It allows you to kind of do an operation that wasn't super easy before. I have a document, or I have a user. Here's my user. Give me other similar users, right? And if you look at kind of like some of the kind of like how modern teams do recommendations. So actually first, like why is that useful? It's because then you can get a list of things that you can like rank and that you can generate recommendations for, right? And if you look at how modern recommendation systems work, they kind of have a few stages. They have like a candidate generation phase, which is like give me a list of things that I should consider ranking. And then they have a ranking phase where they actually do the ranking, and there's a filtering phase mixed in there. And sometimes they kind of like iterate on that a couple of times. So for example, at Google, coming back to the Google thing, we had to rank like literally millions of ads, right? And how do you do that in real time? Well, you can't use this super, super expensive model. We had this gigantic logistic regression model. It's really expensive. You can't just score every single ad every single time. We had this thing where we would do a really lightweight based retrieval, like the super cheap operation to go from 1 million ads to say 10,000 ads. And we had a slightly more expensive operation to go from 10,000 to 100. And then we would say, okay, let's use the good model to score all 100, and then we'll rank by that, and then we'll only choose the top 3 and show the top 3, right? Something like that, right? That's not exactly how it worked, but that's how like modern recommendation systems work. And in that world, where do vector databases fit in? Vector databases fit into give me the list of all the things that I should be considering. I've got this, maybe I've got this user. I want to get a list of other users. I've got this like item, whatever, or you can do a cross entity too. You can say, I've got this item. Who are the users that are most related to this item, kind of thing, depending on how you set up your vector space. And how does that fit in with feature stores, feature platforms? Well, feature platforms are kind of helping the next stage of the recommendation, right? Where I say, okay, I've got these items. These are the 100 items that I want to consider ranking. Now I want to make a really high quality prediction for each of these 100 items so that I can then sort by those predictions. So what we would do then, after you go to your vector database and get that list of 100 say item IDs, pass that into the feature platform, and the feature platform will say, okay, here's 100 feature vectors. For each of those items, here's 1,000 features that are up to date, real time, really high quality. Your team has chosen them before. Maybe they can be based on user information, session data, item data, whatever it is. And then you can score every one of those 100 items, get a relevance score, and then rank by that and just choose the top 3. So the vector database and the feature platforms side by side work really well for a lot of use cases. And so it kind of does make sense. So they're very compatible is my point. And then I think there's a kind of a question of like, what does that mean for like Tecton generally? And what we see with Tecton is we are really trying to help people build these real-time ML applications. Like production machine learning, we just want to be the kind of like platform where you get all of the tools you need to assemble like the production data flows that your ML system runs in real time. And so certainly a vector database could fit in there in the future. We don't do that today because I was just mentioning like we're trying to get really good at one thing before we expand. But in the future, like we want to be this kind of like real-time engine that supports all of the real-time ML operations you might need, and so we could definitely like candidate generation fits into that. And I think you can get if you combine feature candidate generation with feature retrieval, you may be able to get some really nice performance optimizations that you could not get if you were operating these things completely separately. So that's something that we're thinking about for the future. But we try not to one of our cultural values is, and I think this is like a thing that like every ML company has to deal with, is fast but focused. And so we keep our team, try to stay very clear on focus. Let's get one thing done really, really well, and let's earn the right from our customers. Let's wait till our customers are like pulling the next thing from us because they're so happy with the existing thing. And so, feature platforms are still new in the industry too. So there's a little bit of a way to go there before we kind of like expand to all these other things.
And I guess it's kind of becoming a little bit more easy to do that as well, to bring in at least vector nearest neighbor search capability to a feature platform, because now all of these players like Cassandra and Redis are kind of implementing the nearest neighbor search natively, right?
100%. And it's also a just like it's an interesting question about this. So this is a thing I don't have a really strong opinion on. I would love to hear what you guys think, but what is the future of a vector database too? So we know that there's a lot of systems that are vector databases that are kind of like companies that we're a vector database company. We also know So there's kind of two kind of like risks for vector databases. One is, okay, like Cassandra and Redis and, like other companies just add for their like Postgres, just add a vector approximate nearest neighbor retrieval interface to their database, and then suddenly they're a vector database. And do the vector database companies have enough of a moat such that people will go to them, or is someone just fine just using Postgres for this, right? And this is a thing where like the right answer depends on the details of your use case, your requirements, your kind of like, what's the scale I need, a whole bunch of like technical nuance. Then you get to technical nuance. The other thing is a lot of the reasons, a lot of the use cases for vector databases today are to retrieve embeddings for items that you want to pass into prompts for LLMs, right? And that use case, I don't know the future of it, because the reason you have to do that is because your context window in an LLM is only so long. It used to be whatever, a couple thousand tokens, and now it's going up and up. But I just saw Anthropic released a model where it has 100,000 token limit, which is huge. That's like 70 whatever, some number of thousands of pages or something like that. And what's it going to be next year? It's going to be maybe 100 times that. So is that use case going to be around? Are we going to have this problem? We're going to fit stuff into that.
A longer prompt costs, right? So it's a huge cost to pass, I guess, 10,000 tokens to prompt.
No, it is, but I totally agree. But that's a problem we have today. But then I think about then we try to solve that problem, and maybe there's a way to cache, like cache and reuse a LLM halfway through processing a prompt or something like that can allow us to reuse the state of an LLM once it's already had some level of a context window having been processed. And so anyway, all of that is just to say that we're very early in this space. There's a lot of uncertainty, and so there's a lot of big questions for the futures of vector databases.
I think we will be. I think that vector database or databases, vector functionality, jobs to be done around vector databases will stay with us. I expect that yes, the prompt can be you will be able to send bigger prompts, but I think that we will that embedding and vectorizing stuff is more about the essence is in extracting essence and having it in a concise ways. So I believe that we will be also using prompts with vectors to make them shorter and also save some processing time on the large language model inference. But it is what I feel when it comes to companies around vector databases. I think that the core functionality is so low level that most likely it will be basic offering of a cloud provider like vector database.
I agree. It will be so. So yes, it will be an offering from a cloud provider. It will be an offering from like Reddit. Redis already has it, right? Like folks like that. And then I think the question is, but does a specialized vector DB have enough kind of like unique value to kind of economically justify its existence as a separate company? And
I don't believe. I don't believe.
You don't think so? Yeah. So I don't know.
I guess speed is not that important, right? Because vector-based databases probably provide speed, I guess, over a regular, let's say, Redis.
I think it would be tough to beat Redis on speed, but there's probably a lot of we can imagine a bunch of dimensions: developer workflow, cost, flexibility, types of, there's a whole bunch of things like how many vectors can you retrieve at the same time, performance cost trade-off, stuff like that. All of those things, this is just like a whole area where there's a whole bunch of solutioning that can be done. But I agree. Like, I don't think vectors dealing with embeddings is going away at all. I think it's super powerful. We have people putting vectors into, like, embeddings into the feature platform, where they're retrieving those as features. And some of the things that we want to be doing is helping people build those, helping people, because they're just features, right? And helping people keep those up to date and manage all the versioning of that. That's one of the things that was super valuable actually at Uber. It was really successful for a lot of the stuff, particularly in Uber Eats. I just remember that team adopting embeddings and going crazy with them, and they got a lot of stuff done, a lot of impact from that. So we're really bullish on embeddings. We think there's a lot to do there, and so that's actually a pretty big focus for us in the near-term future.
Can we go a little bit into the topic of real-time machine learning? Because I know that if I remember correctly, Tecton is pretty bullish on real-time feature engineering compared to other feature stores. Can you go a little bit deeper into how it's going, and is it needed?
And what it's about? For me, who is not following so deeply feature store space, what real-time feature store is about, like, to start?
So let's take a step back and talk about, like, why would you ever care about real time? Who cares about this? And so I think there's a little bit of, like, a data maturity thing that people go through. So when we talk to companies, there's some companies who are just at this stage where they're just like, we have all of our data. We don't even know where it is. It's all over. It's in random databases in the company. I don't even know how to access the data. So that's kind of like the least mature kind of, or we don't even have data, right? But, over time, companies get to the stage where they've got their data together. They put it on a data lake or a data warehouse. It's on the cloud. It's kind of like in this, place where people know how to access it, and maybe they can start doing proper governance and BI on it and stuff like that. So then the next natural thing is, let's get some analytics from this thing. Like, let's use this data for something useful. The easiest thing to use the data for is to extract patterns, to make dashboards, to make decisions, all this internal stuff. Let's have a meeting. Let's look at the data. Let's make some decisions, right? Or let's pull up the dashboard, or do alerting or something like that. But then you kind of get to this, okay, we've done that, but how do we actually use this data how do we get more value out of this data? How do we use this data to affect our customers? This is kind of the same question we were talking about, like the Uber thing, where they were like, let's do something cool with this data. Let's use it. Let's differentiate our product. Let's make our product better. So that's when you get to this set of decisions that need to be made with the data that happen at a speed and a scale that you can't really have a human in the loop. And when that happens, you need to productionize things. It's got to be, if you're going to use it to affect your customer experience, it's got to be productionized. It becomes a little bit of an engineering problem too, and you have all of these requirements. It's got a certain level of availability. It's got a certain speed that needs to happen. Certain, cost requirements because it's like a certain scale. So that's when you have machine learning in production. That's like how people get to the point of machine learning in production, and they want to use machine learning for a variety of problems. The highest value problems, though, are every company has, like, what we've seen is, like, there's a variety of use cases that kind of are this is the most important use case for us, and then we have this, like, long tail of ML use cases. When we look at what are the most important use cases for companies, it tends to be stuff that, like, directly makes money for them or directly prevents them from losing money, right? And so these are recommendations. If you make better recommendations, you're making more sales. Fraud detection. This is like, if we prevent fraud, we're saving a lot of money. Pricing, better pricing, risk decisioning. So like stuff like real-time underwriting, or underwriting from if you sign up for insurance or a credit card or something like that. And so all of these use cases, the ideal user experience, kind of like if you're competing against your competitor as one of these companies who's in banking, is in insurance, is in fintech, whatever it is, you're getting pushed to go faster and faster. A better user experience is a faster user experience. And I'll give you an example from a specific customer that we have. They are an insurance company, and if you would sign up for insurance with them, they run everything on a mainframe, like on their data center, and they couldn't give you a quote. They had to take that quote, they had to take all your information, they had to go back to like literally put it in some queue, and overnight the mainframe would process it, and the guy would call you the next day and say, this is how much we can give you this policy for. So they're all about like, how do we just go faster with this thing? How do we make an instant experience for our customers? So all of these companies are trying to just build a higher quality experience for their customers, and that means going faster. So that motivates real time. And so
it is near real time still, right? Because we are talking about kind of extreme batch overnight processing of requests for credit, right?
Well, what I just told you was the overnight thing, and I'm saying that was too slow for this insurance company. They were like, "This is dumb that we have to do this.
Yeah,
why can't we have in the app? You say, okay, now I want to sign up, and it gives you your price instantly, right?
But instantly, 1 minute will be fine. Or we are looking here.
Well, they want to give you the price instantly. Like it's kind of like if you search Google and then Google's like, okay, we'll give you your results in 1 minute, right?
Yeah.
You get a lot of drop off there. So all of these things, like certainly getting it 1 minute later is better than getting it 24 hours later. But if you have your competitor who's going to give it 30 seconds or 1 second later, then that's your incentive to go faster, right? And that's why Google's super fast. And all of these companies, they want to be super fast as well. And so just to like think of some other examples where speed is important, you're processing a payment and you have to decide, should I allow this or not? Or are you sending a payment to somebody else? You want to know, did it go through? You don't want to like wait to get a text message 5 minutes later if it went through. Or someone's loading a page and you want to show them a bunch of recommendations. You want to show like recommendations now, not later on. And so there's like a whole bunch of these examples where like that kind of speed matters. So they think about, so now they think about like, how do we do this, right? Well, what is involved in this problem from an engineering perspective? The problem is we need super high uptime and reliability. Like number one, like we don't want this, any way we solve this to just like break things. Because if it breaks things, then like we're definitely losing money. But they have a bunch of data that comes from the customer. It comes from some recent data source, right? It could come from maybe the user session, 5 seconds ago in the user session or 10 minutes ago in the user session, also in some use cases. But the kind of common thread is this data needs to be processed really quickly and used in a machine learning application. So the recent context, the right now context, where is this user? Like, is this user in their home country? That's a really good fraud signal, right? Has this user tried to make 100 payments in the last 10 seconds? That's kind of fishy. Is the size of this transaction $1 million? That's kind of weird too. Like all of these signals, those things, people want to use them in their decisioning and use them to power their real-time experience. So that's a tricky data engineering problem. It's hard if you're a data scientist. So we have this engineering problem that's really high value. If you solve it, it's going to make a difference for your business. If you provide a better product experience than your competitor, and you want your data science teams to be able to do this properly, but your data science teams, they just know Python or R, and they've never done anything in production ever. That's the kind of situation a lot of companies are in. So how do you kind of bridge that gap? And how do you allow the data science teams to be able to build things that go to production and do it at a speed that is efficient, meaning like you're not paying for the data scientists for the whole year and they only put one thing in production, but they can launch things regularly. They have a good development and innovation velocity, while you're still maintaining all of the constraints you care about from an engineering perspective for the production system. High uptime, it's real-time serving, you're meeting your certain latencies, it works for your scale, all of these kinds of things. And like fits into your CI/CD process, you're meeting your data governance, compliance concerns, all of that. So that's the kind of like fundamental challenge that a lot of teams who are in this fintech, insurance, banking, e-commerce, gaming, security space, they all have some kinds of problems like this. And that's the core thing that the feature platform, real-time feature platform, is intended to solve. Any kind of like batch tooling, it just doesn't have any, it's like not related. And what people are stuck doing, It's just it's literally, this is what the best solution is today. If you don't use a feature platform, it's hire a bunch of engineers and get them to custom build data engineering pipelines. If you don't have or if you don't have a feature platform, and do that for every single feature. And that's a very expensive thing. Like, this can be, okay, now I got to pay 10 people salaries for a year. I don't even know if it's going to work. The thing that they're going to build is going to kind of suck. It's going to break a lot, and it's going to be expensive to maintain. So that's where we come in, and that's where we hope, that's the kind of difference we hope to make for an organization. We say, don't do all of that. Just buy a really simple solution. We've built that to help people get to production. Sorry, I just ranted on a lot, but I want to pause and let you guys interject however you want.
It's very good. Like, for me, I understand the problem, right? But it sounds for me that there is a second, maybe less important. A question for you is, like where you felt was the biggest challenge here? Like, the second part is serving, because I understand with Tecton, you can, or online feature store, if you want to be generic, you can, on one hand, set a process for your data science team to develop features in a way that you can easily use them on production in a scalable, fast way in near real time. But so feature part solved, right? But then we also need to pass it through a model to get. But maybe this second part is, when I'm asking a question, maybe it's less challenging once you have those features under control.
Am I correct to think that the hardest problem for you to solve was the real-time feature engineering piece? Because to me, as an ex-data engineer and still data engineer at heart, like getting back from failures in real-time feature engineering pipelines is a mess, I would say.
Yeah, so I think there's kind of like, there's a couple of parts here. One is the technical challenges in all of the real-time data engineering. And then the second is the developer workflows for the data scientists or the users, right? It's not always data scientists. And so it all comes down to this kind of like interface of a feature. So basically the innovation of a feature platform is, hey, you have this thing, you can define a feature, and as long as you kind of define it within the certain bounds of like what is its definition, who owns it, should it be online, offline, all of those things, then this system promises that it'll deploy it in this way, and it'll manage all of the infrastructure and all of the orchestration and all of the serving and everything for you, and it'll just be like productionized magically. And there's a bunch of problems there and behind the scenes that are solved, which are really hard and we can talk about. But from the data scientist perspective, they get this nice interface. They just say, here's my little snippet of Python code. Here's my SQL query. Or maybe even using a DSL. Here's my like aggregation that I want to have in real time. And I get this interface where I can say, give me the real-time feature value, the latest value that my production system can plug into, or give me a training data set. Give me a backfill this feature, give me all this historical data joined with a certain point of time, help me prevent label leakage, really high quality data set, right? So from their perspective, they can do that really fast, and it's like there's no engineer needed for them. They can just kind of like register, read features, share features. It's like a really nice interface for them. On the behind the scenes, kind of after they've registered, they put the feature in the central repository. That's where there's a lot of like really crazy technical challenges, where just some things to mention are, so we have a couple of there's some like really obvious things that are always there, like real-time serving. We have a lot of IP and how do we support all these different ways to do real-time serving, multi region, failure recovery, things like that. Real-time feature compute. So we have a class of features which is computed using the data that comes from your application when you're trying to make an inference too. Like, you just filled out a form and you want to featureize that data as well to pass it to your model. There's we run Python in real time, and we run it really quickly so we can turn that into features and give it to your model. But then we also have, I think this is like one of the actually like the really nice values of the system that we've built that our customers really love. We have these modules that are kind of like managed feature pipelines. So a very common one, a very prominent one, the most popular one, is the aggregations module. So, one very common type of feature that fraud teams use a lot is aggregations, literally time window aggregations or lifetime aggregations. How many times has this user made a purchase in the past 3 minutes? That's the kind of feature. If it's really high, there's something weird. Or how many times have they ever made, what's their total lifetime transactions with us? That's another trust signal, right? Doing that in real time at scale and meeting a certain level of cost efficiency, and being able to have the consistent data offline and be point in time correct. That's really hard. That's the thing data scientists don't do. It's a hard problem for engineers. And we've just got this module that just kind of like automates all of that. We have like best in class implementation for it, and it's like super efficient. Our customers love it because they don't have to build, they don't have to invent this stuff. And so it's just another place where there's IP where we can make things easier for people and run like really high, highly productionized, best in class designed or best practice designed modern feature pipelines by just giving people like really simple APIs to define them. So I think that's kind of like a little bit of a walkthrough of the different systems. And of course, there's kind of like monitoring and governance and sharing and a UI to see the catalog of all the features. But I think like the things I just mentioned are like the unique differentiators and like why you would buy the system, why you would like use it. Does that make sense?
Yeah, but is it a secret? What kind of stream processing framework you're using behind the scenes, or is it something completely custom?
We actually have two. So there's three kinds of. We'll just take a step back. There's three kinds of features generally that you can think of. One is batch, super obvious. It's like here's a SQL query. We'll run it on some schedule, and that will be the new feature value. Second is streaming. So that could be a streaming aggregation or any other kind of like streaming operation you want to run. That's good for like session type things, like how many dollars have you spent in the last 30 minutes? And then the third is this real-time feature compute, which is like right now synchronously coming in from the request for the person to sign up for insurance. They filled out all these forms. They gave us all this information. We got to process it right now, turn that into features, and then make a prediction with it. And so you're kind of talking about that.
And are you doing
we do all three.
as well?
We do all three.
Oh, okay.
Yeah.
I didn't know that you're doing the third one.
So number three is like we've got a whole like real-time execution engine that kind of makes that super easy for people. So that's a really big thing for us actually, and fraud teams love that. But the second one is so the second one, that's kind of like the streaming thing. And so we have kind of two answers here. So we will both plug into, if you have like a Spark cluster, if you have Spark, we will run a lot of the streaming compute on top of Spark, use Spark structured streaming, and give you the flexibility to run whatever kind of Spark stuff you want. But we also run our own kind of streaming compute engine. This is kind of like developed within Tecton, but focused on these like specific performance optimized feature pipeline modules, like this aggregation thing I was just telling you about. So you don't need Spark, and you can come to Tecton and you just say, look, I've got a Kafka stream. It's got transaction events, and I need to know exactly how many events happened in the past X, just like basic aggregations and some more complicated stuff. And you don't need Spark for that. It's something we built, but we can achieve a level of performance that you can't really find elsewhere because we're doing optimizations that are really specific for the ML feature engineering pipelines rather than like generic data streaming use cases. Does that make sense?
It does. I was wondering if maybe you're using some Flink clusters underneath, or
we don't use Flink.
Mm-hmm.
No,
okay.
I know. Like we actually used Flink at Uber, so there's nothing. Don't have anything against Flink. We used Spark originally at Tecton, and we've had a lot of the new stuff we're building to be so you don't need Spark. So folks who don't need Spark should be able to come to Tecton and have like a really great experience as well.
So Mike, we are both founders of point solution in MLOps space. We have customers and end users who are data scientists. And I'm quite sure that you're also asked this question. I was asked firstly by the board. Piotr, we are hearing about GPT, foundational models, large language models. What is the implication? How do you see implication of large language models of MLOps space and on our end users, on data scientists, ML engineers. What is your take on that?
So I think the large language models are really cool because they're a new interface to dealing with data, and they're a new kind of reasoning that can be done. What that means to me is like new use cases for machine learning. But what I think a lot of people are a little bit maybe worried or whatever it is that, oh, this stuff is just going to take over it's going to replace all of the existing machine learning, everything that happens. And I don't think that it's going to happen anytime soon. And I really don't think there's a chance of that at all. Why is that? Because, large language models are super expensive, first of all, and they're good at unstructured data. The problems that at least my team deals with is this is kind of like another way to phrase some of the problems we were just talking about. Look, we have all of this structured data. We need to make a prediction really fast with it, and we need to have it like be quite interpretable, and often it needs to be deterministic as well. That's kind of like the exact opposite of LLM. It's kind of like, our customers are like, we need to run 100,000 recommendations per second, and it needs to be optimized for this scale, and we need to have it at this level of cost. And LLMs are just not good for those kinds of use cases. Maybe 10 years from now, something will change, and LLMs will be so cheap that you might use them as the model to interpret a bunch of features, and they'll be so fast that it'll be fine. But I see the main MLOps stuff not really being honestly that affected by it for production use cases like the ones I'm talking about. These like
it is still early, right? But maybe not very often. But I've seen at least a couple of times where you have a mix of structure and unstructured data to serve that you need to process to serve your customer. How do you see classical ML or classical deep learning working together with foundational models? Do you see does it make sense?
I don't know about classical deep learning, but I do know like where like the feature stuff, that the data layer for ML fits in with LLMs, where we have a blog post with the LangChain team where we have, if you go to like the LangChain docs, there's a like, what's the deal with feature stores and LangChain? There's a post about that. It's in the documentation too. And basically, we have a bunch of examples of how you can use that, how they fit together nicely. And so like, how do they fit together nicely? Okay, imagine I'm using an LLM to do automated customer support, right? We need to pass in some information, like the prompt we want to give to the model. We want it to have all of the data about the customer so the model can do the right reasoning about the customer's context. Well, what does like the feature platform do? It's the thing that's creating and maintaining the customer or item or market context in real time, always fresh and always ready to serve in a productionized way. And that's what these systems need. So in a LangChain, you can create a prompt template that calls out to like a Tecton or another feature platform to say, okay, give me all the features that are relevant to this customer success problem. And then, the model will make process a bunch of logic based on it.
You're providing values to template, right?
Yeah, exactly.
Template. Yeah, makes sense. What about agents? Do you see?
I gotta say, I haven't really we haven't seen that too much yet. I think it's kind of early for agents. I think they're super cool. Like, I'm really excited to see what happens with all of the agent stuff, in the next couple of years. But when we look at what our customers are doing today, they've never said the word agent to me. So I think they're a little bit farther behind there. We're looking ahead at that, but it's still a pretty big gap.
So before closing up the episode, I want to ask you, Mike, do you want to leave our listeners with any thoughts?
I think the only thought to leave here is that there's been like a lot of hype over the past 2 years about feature stores and feature platforms, and everybody's heard of them. it's kind of a, getting production machine learning right is a hard thing, and building an ML platform is a hard thing. One of the things that we do is we just spend a lot of time like meeting ML teams and helping them just understanding their ML strategies and seeing if we can help them kind of go in the right direction from an ML infrastructure or ML platform perspective. And maybe it's a good idea for them to use a feature platform or not, but I spend a lot of time talking to those teams to help them figure that out. And so this is kind of just like an offer I'll put out there, but you can always send me an email, mike@tecton.ai, and we'll come and chat with you guys. And, we want to help out the community. Very interested in getting kind of like added sophistication, more best practices out there for ML platforms. So to the extent that might be interesting for folks, just get in touch with us at Tecton. We can spend some time with you and help you out.
Okay, thank you, Mike, for jumping on the show. And thanks to everyone who was listening, and see you in the next episode.
The ML Platform Podcast was brought to you by Neptune AI. If you'd like to learn more about ML platforms and MLOps, check our blog at neptune.ai/blog. Follow us on LinkedIn or subscribe to our YouTube channel. Also, check out how we help teams solve MLOps challenges with our experiment tracking at neptune.ai. To get notified of future episodes, follow us wherever you get your podcasts. Thanks for listening, and see you next time.